Hello. I would like to talk about 2.3. So first, I will introduce some uh, concept and define some important define this finite frame. So consider curve beta from I to Euclidean space, and so for example, a curve like this. Um, we assume this curve is a unit tangent curve. So for each point, we have a tangent vector, and we assume the tangent vector, the magnitude of the tangent vector is 1. So this is our assumption. This is the one. And this vector, we call it t, tangent vector t. And since this vector, the magnitude of this vector is fixed, so what we interested is to know about the derivative of this function. Since the definite derivative is uh, is not a is not zero because this is not just a real value function. So the derivative is actually uh, the t derivative is n. Okay, so and the relationship and the n is representing um, like how the curve is how the curve is changing the direction. Okay, so then what we have is because of what we know, uh, t derivative is equal to n. So the relationship is kind of like uh, what we have is kappa n. So if we want n to be a unit vector, so we derivative this t, and we got a vector, and then we want to have the unit vector of that direction, and that direction is must orthogonal to t. Okay, because t is a unit vector, so there is no changing in the speed. Okay, so it is a constant speed. So the direction of the derivative of t is must orthogonal to t. Otherwise, there will be um, a component along t, along the direction of t. So the speed will be increasing or decreasing. And what we see here is if this uh, derivative of t is have some vector, then it doesn't have to be a unit vector. But what we want is we take the unit vector, just like we take unit vector for natural frame uh, coordinate like x, y, and z. So we just do it like here in here. So uh, we got a t derivative equals to kappa m, and the kappa is called curvature. So because this is because we want to define a natural frame, frame like a natural frame like x, y, and z. This is a three-dimensional space, so the dual space should also be a three-dimensional, and the like the z coordinate is what we want here is perpendicular to this plane of the iPad. So it should be b equals to t cross product n. Okay. So now we got three orthonormal bases, the orthonormal bases, like in a linear algebra. So and so the lemma 3.1 just introduce this frame, this T N B is a three orthonormal bases, and they are called together form a finite frame field. Okay. So for each point, we have this frame field. So next is the most important theory I want to give a brief proof and introduction is this finite formula. The idea behind this, actually the motivation behind this is we want to know an arbitrary unit speed curve. What is the relationship between t and t prime, n prime, and b prime? And what we want is the change because for each one the changing have a physics the meaning in physics, so they are important. So what we want to know is the derivative of each three component, and what we have is the what we have is T n and b. So we want to use Tn and b as the the basis we have, and to express the T prime, N prime, and the B prime. So this is kind of like how was the linear combination is formed by Tn and B, and the relationship between this differentiation and itself. So the first thing is the first formula is very easy to notice, because this is exactly how we define n. Is the t derivative is just the curvature times times n. N is actually called uh, principal normal vector field. So it doesn't matter what's the name, but I just mentioned here. And next easiest to see is b prime is just a constant, also times n. And this constant is the opposite value of a physics term, a very familiar term from physics. It's a torsion. Okay, then how to prove this? This is easy because we can we can differentiate b dot product t equal to 0, and what we have is in both sides we will make a differentiation, and we got this thing, and because we know is this, so we can use the first equation to plug in here, and we got this result, and we can easily see how this is relation. Okay. So next is what we want to know is what is the n prime? Actually, the n prime is very interesting. N prime is curvature times t plus tau b. This is tell us the first equation is from the original speed. The original is actually acceleration, and the last equation is the torsion of is the torsion times the principal normal field. And the third equation is tell us there have two components. One is the curvature times the t, and the other is torsion times b. And actually we can see the positive negative feature is just opposite to the first equation and the second equation. So they together is kind of beautiful because this from a symmetry. And how to prove it? The proof is not hard. Let me prove it. N prime is just what we can use from the first from I remember from the former sections. We can use this formula. And the next is just some basic calculation. So that's the plugin what we have in before, and then now we calculate this. So now what do we have? What plug in back to it, so we can get the original equation. The proof is not hard, but the iteration behind this is very interesting. So I will not go further to example. So next section will be arbitrary speed curve, and I will post another video for that. Thank you.